Okay, so welcome to week 2 of Machine Learning Zoomcamp. So this is office hours, and during these office hours, we will walk through the homework. There is also a pinned link in the description. You can use this link to ask questions. And yeah, let's start. So I have a Jupyter notebook somewhere. So yes, so this is the homework. So let me also open the task that you had to do. So so the purpose for this homework was to first of all set up the environment. So for this homework we need pandas and numpy, and then download the dataset that we will use for week 2, meaning this week, and play a bit with this dataset, experiment with pandas and with numpy. So I already downloaded the dataset from here. I used this wget command to save it. So now I need to read it. I think that's the name. Yeah. So this is the data frame we have. So I'll save it to a data frame. So the next thing we need to check now is what's the average price of BMW. So for that, there are multiple ways of doing this. So one simple one is, for example, you can just use this df.make and filter all the BMWs. So this way you get a data set only with BMWs. Then next you select RMSE, and then you look at them in, sorry, not RMSE, but this manufacturer suggested retail price. Yeah, right. So this is the answer that you need to put. Alternative could be, let's say, we can group by make, and then see what is MRSP for each group. So you see, like this will be for each car make. What is the average price? So we can make it a bit rounder. Let's up to 3 digits. And we see that for BMW, that's the response, and we can also see for all others. So these two ways, they should give the same result. So this one is a bit more verbose. I'll remove that. Okay, so this is how you find the average price. And then the fourth question was select a subset of cars after year 2015. Apologies that it was a bit unclear. Here I meant inclusive, so 2015 and after. And we want to check how many cars have missing engine there, horsepower. So here equals greater or equals. So this way we get a subset of cars that were created after 2015 or on 2015. And then, so what we want to do there, look at the null values. So now we get like this data frame with where each cell has false or true, depending if it's missing or not. And then we just look at some. And here we see that this engine horsepower for cars after this year, there are 51 missing values. So alternatively, you can also immediately check engine horsepower here, HP. And then you don't need sum here anymore. You just immediately check how many values are here. Yeah, actually you do need a sum because you have binary series with binary data. Now you need to find out how many of them have null values. So this is how you do this. So then the next one was to check the mean before like different options of filling missing values. So yes, here we need to first calculate the average of engine horsepower in the data set. So this is how we do this. So we get a mean. Let's call it mean horsepower. Yeah, and now we just do the same, but we fill the missing values with fill NA method, and we just use this thing we just calculated. And we see that mean hasn't really changed like before and after. So, and instead of mean horsepower, let's say you replace it with 0. So with 0, the mean is actually different. So, okay. So what we do next is, yeah, so this was question 5. Right. So the question 6 is, this is where most of you had problems. So let's do that. So first we need to select all Rolls-Royces. We do this by using this Rolls-Royce. Right. And then we need to select these 3 columns: engine horsepower, cylinders, and highway MPG. Right, so this is how we do this. So we use this brackets notation. Yeah, this makes it quite big. So we have a lot of duplicates here. Now we also add one more condition here: drop duplicates. So now we should have only. So I don't know what happened here. So now we should have only 7 rows, right? So I'll call this data frame RR for Rolls-Royce. So we have this data frame, so with just a bunch of observations. What we can do now is get the numpy matrix from here, numpy array. So let's call it X. So we have that. And yeah, so this is our X. And next we need to compute matrix multiplication between the transpose of X and X. So to get the transpose, use X.T. So this is what we do here. So this is how we get X transpose X. So you see it's the same, but every every column becomes a row. And then if you read carefully what it says, compute matrix multiplication between the transpose of X and X. So here order is important. So first you need to get the transpose and then multiply it with X, right? And then you get this 3 by 3 matrix. And if you change the order, so instead of doing X, like if you first take the matrix and then multiply it with the transpose, you get a different matrix. So this matrix is 7 by 7, right? So this one, you see that matrix multiplication is not the same. Like it depends really on the order. So if you take first the transpose and then multiply, you get a 3 by 3. But if you switch the order, you get a 7 by 7 matrix. So this one, this is what you should do and not this one. And now let's do X transpose X. And yeah, so we have this matrix. Now we need to invert it using this link alg inf function. So we get an inverse. Let's call it xtx inf. And we need to calculate the sum. So this is the value you should get. And hint there was like if you, when doing this, you get a negative number, it probably means that you change the order here. Or another option is that this value can be very large, like the huge number. So I don't know why sometimes it's negative, sometimes it's huge. So I don't know. But basically, so this is what you should get. This is the answer that you should get. Okay, and the next one is, so the final question is we need to get the matrix, the vector y. So with these values, y. So we get the y, and we need to transpose this this inverse. We need to, get the inverse, multiply it with the transpose, and then multiply it with y. Okay, and actually, so this is what we just implemented is, let me just write it. So this, we implemented a normal equation, which is this X transpose X inverse then we will multiply it by X transpose, and then multiply it by Y. So this is what we implemented. And yeah, so this is our W. This is for those who already started the week 2, the lessons from week 2. You probably saw this already. So this is what we use to actually train a linear regression model. So we have this W. So these are the parameters of the linear regression model. And what the question was asking is this value. So the first element of W, yeah, maybe it's a bit confusing. So I should have set element number 0. Yeah, but basically I was asking for this thing. Okay, so I think that's all for the homework. Yeah, and let me go to questions. So let's see. So let me just make sure I have the slides. So just one moment. So so I got logged out. Okay, now it works. So here are the questions that I have. Sorry, I cannot keep track with all the comments from the live chat. So if you have a question and you want this question to cover, I don't think I'll be able to track at the same time the questions in the live chat and in Slido. So please use the pinned link, and I'll try to cover that as well. So the first question that we have is, I don't know, maybe let me just check first to see if there are questions that are related to homework, and then we'll start with them, and then we'll cover the rest of the questions. So I think, let me just check. So I use Jupyter Notebook for homework and haven't got other things on environment set up fully yet. What should I be concerned about installing all the rest? When should I? Yeah, right now. So if you don't have the environment, you will not be able to do the rest of the course, basically. So the rest of the course is coding, and if you don't finish it, if you don't set up the env, you will not be able to do this. Why did you do the transpose? Well, I'm not sure what you are referring to. You probably meant in the formula. So this is just the formula for the normal equation. And you can check in the week 2, we will look a bit more closer. We will not go into too many details of this normal equation, but we will cover a bit of this. So you will probably see why we did the transpose there. Are late submissions for week 1 homework accepted? They are not, sorry, because I just presented the solution. So if I keep accepting the homework, then you can just, copy the answers from there. Can you put the homework solution in the repository? Yes, of course, I will do that. What does XTX inverse sum mean? It doesn't mean anything. It's just I wanted to check that you know how to invert matrices and you know how to use the sum method. So in this particular case, it doesn't mean anything apart from that you can do these things. Okay, let me start from the most voted questions. So what are the must-have resources, materials for a beginner in ML AI? Yeah, that's a very broad question. It really depends on the background you have. So let's say if you're a data analyst, then you probably learn things differently from, let's say, a software engineer. Or if you're not coming from IT background, then you probably want to take a different approach. So it really depends on your background. For me, what was helpful is the course on Coursera by Andrew Ng. That is very old, like from 2012. So this was one of my first courses. And then also what helped me was Kaggle. And yeah, of course, this course is based on my book, Machine Learning Bootcamp. And I hope that at some point somebody will say that this is a must-have resource for a beginner and in machine learning and AI. I'm a bit biased there, of course, so I might say that, but I don't know if it's necessarily true. So I'll leave this to you to decide if it's the case or not. So what does it mean? Feel free to submit PRs with links to your notes. So let's go to the notes. So we have this course repo here. This is my profile, and we have the course repo here. So it's here course Zoomcamp. So here we have, let's say, we'll take, I don't know, let's say linear regression here. And so we have these notes, add notes from video, PRs are welcome. So what I mean here is that you can actually, like, let's say you watch a video here and you took some notes and you want to share these links with these notes with your fellow learners. And you can do that by taking these notes, putting them somewhere, let's say on Notion or Medium or GitHub or whatever you prefer, some online page. So you can put them there and just create a pull request with a link to your notes. And then somebody who maybe doesn't like watching videos, they maybe can just go through your notes and read them. So that's the idea. And then even better, like instead of adding links, you can add notes directly here. So people do not need to go to some external site. They have everything here in the repo. That's the idea. So I do not have time to do this, to have notes myself. That's why I added these notes. So if you have time, if you want to contribute, and if you have some notes, so you can contribute your notes and help everyone with that. Wow. Okay, so where's yeah, so this question, when it is preferred to use Maya metric instead of RMSE, I am afraid most of I don't know how many people actually started to watch the the session about regression. So I will keep this question till the end because this is a question about the content of week 2, which just started today. And yeah, so let's first cover the questions we have from the week 1. So I used Google Colab to submit homework 1. Can I use it for the rest of this program, or it's recommended to set up a local environment in Linux? You can use Google Colab. Yes, definitely. I don't see a problem why you cannot. So setting, yeah, so with a caveat that for deployment sessions, it will not be possible to use Colab, most likely. I don't know how. To use this for that. So you will need to have some sort of local environment or something in the cloud where you have access to the command line and you can execute things like Docker, then you can access Python interpreter there. So Windows should work. Linux or Mac OS is probably the best option. But on Windows, if you use Windows 10, there is actually, I'm on Windows right now, and I can show you that. Yeah, so here I have this Windows subsystem, like Windows subsystem for Linux that I'm running basically a Linux right here. So I can have all the usual Linux commands like, I don't know, Git and whatnot. So I recommend you to try to do that. And yeah, otherwise you can just use plain Windows as well. Can you collaborate with startups so we can get chance of internship after the bootcamp? I don't think I can, because that's just, there are not so many, like it just takes a lot of time. So first I need to record the videos, prepare homework and do all that. I cannot imagine adding to that also collaboration with startups. So maybe sometime in the future, I don't know. But if there are somebody from the startups who are listening right now and you want to hire people who graduate from this Zoomcamp, please reach out and let's arrange something. How can I practice writing codes from formulas better? Yeah, I do not know, to be honest. Like, first thing is probably what you need to realize, especially when it comes to matrices, that all these things like matrix multiplication, for example, everything can be expressed with Python code, right? Or with just any code. And once you see that, then you can just take a formula and try to decompose it one by one and try to see how it translates. I don't know if it actually answers your question, but there is no better way than just try and translate. What also helps is when you have a reference implementation. So let's say when we were implementing matrix multiplication in plain Python, so we could compare the results with implementation from NumPy and see that the results are the same. So if you have some existing implementation, you can compare your implementation with the reference implementation. That probably helps. How is ranking different from the regression model? So yeah, I think in one of the videos, I talked about the three different sort of subtypes of supervised learning: regression, classification, and ranking. And so in ranking, let me open that. So in ranking, so let's say for regression, let's say you have a car. So you have a car. And then, yeah, so extract your feature matrix from that car. You apply the formula, this G function that you trained, and you get a prediction, like, I don't know, price. So you do this for one object. So this is, you get one car and you do prediction for one car, right? When it comes to ranking, you don't have one object. Of course, like you can have multiple cars and apply this to multiple cars. But the core difference with ranking is in ranking, you usually have, let's say you have some results from Google. So you have some query and you have some results from Google, right? So there could be, let's say, results from 0 to 99, and you need to apply a function to each of the elements. So this is a group, and you need to apply this model that you have, this model G, to each element of this group, and then it produces a ranked list. So like you, let's say you apply this G to this X0, and you apply this G to X99, and this X99 is like the row here, the results of the query. And then what you do is you re-rank the output, like you re-rank all these results using this function. So what I'm trying to say is here you look at the group and you try to see how good the ranking is within the group, right? While in simple regression case, you have like more standalone object sort of. But in ranking, it always has to be a group. And then of course this G, when it comes to ranking, this G can also be regression or it can also be classification. But then you always need to think about the other elements in the group. So I hope that answers the question. But this is not something we will go into details. So not in this course for sure. So this is just for you to know that like it's a little bit different. Maybe this is something you want to do for your project or for explore for the article. This is totally fine. Okay. I'm aware of how logs simplify computations involving products, but is NP also prone to? To be honest, I have no idea what this question means. So I'm aware how logs simplify computations involving products. This is floating point errors. Okay, so yes. Yeah, okay. So yes, in NumPy you have these floating point errors. And just for those who don't know what it is, on computers, when let's say we multiply two numbers or when we do some operations, maybe I can have an example. So let's say when we take two numbers you see that we have instead of 3, we have 3 something something something, like a lot of zeros and then 4. So this is again, this is because floating point operations are not precise on computers, and that's why when we do summing or multiplying, we have these little floating point arithmetic errors. And yeah, so numpy, because it's running on a computer, it's also prone to that. But I guess your question is why I keep using logs after the data exploration. You're probably referring to week 2, I think, when we look at the when we use the logarithm of the price. And the main reason for that is not numerical instability, is not because there are floating point errors, but simply because like you'll probably learn about this in the video, is because these distributions have long tails. You please refer to the EDA video, like it's like probably second or third, where I explain why we need to do this. And that's why we keep using logs for that. Yeah, so if we don't apply logarithm, then it's very difficult for machine learning models to actually learn from this data. So how to select approach for cross-validation? Yeah, so far for week 2 and for week 3, we will follow a simple approach. So the simple approach is what I described. So we just take entire data set and we split it into 3 parts. So train, validation, and test. So this is what we will use for week 2 and week 3. And in week 4, we will talk about cross-validation. I will not explain what it is now. But what I want to say is this approach to validation is sufficient for many cases. So yeah, I think it's pretty safe to say that in many applications, just doing this split once is enough. Cross-validation, of course, is nicer, and we will learn more about this in week 4. So right now, and we'll not go and try to explain it. So wait for the video. But this is fine. And so how to select an approach for cross-validation? So I would say that so there are multiple options. So k-fold. Yeah, I'm not sure many people will understand that because we haven't covered that. But basically, if your data set is big, then you don't need k-fold. If your data set is smaller, then use k-fold. Leave p out. I've never used it personally. So, okay, how do we know if we can solve some particular problems by using machine learning? So yeah, that's an interesting question. So the tricky part here is so in machine learning you have this this formula that you saw many times. So first of all, we need to have this thing here. So this is our target. So if we can already think what is the target we are predicting, I'm just thinking of an example. Like let's say we want to understand what is on the picture. We have a picture and we want to build a model for classifying dogs and cats, right? So here in the target could be dogs and cats, like what is present on an image, right? So we need to think about this target. So this target is very important. So if we know what we want to predict, then potentially it can be solved with machine learning. So yeah, basically the answer to this question is you need to think and answer this question. So what is the target variable I'm trying to predict, and what are the features? What are the features that I have, right? So you need to have both. So you need to have target. This is what you want to predict, and you need to have features. If you can express your problem in these terms, like as a feature matrix and as a target, then it can be solved with machine learning. If you cannot, then yeah, probably you'll need to think better, more about this. So I hope it answers the question. So there are many ways of to write codes. Are short codes better in actual jobs? As a machine learning beginner, should I focus on writing concise codes? What is production code? Yeah, I mean, it really depends. So like, actually, I don't think short codes are better than long codes, because long codes are usually more verbose. So for example, if you look at what I wrote here, this is terrible code. So don't write like this. So maybe it first makes sense to, I don't know, first select a subset, right? And then, I don't know, select a subset of columns and then drop duplicates. So actually split it into multiple rows. So because here you can look at this and you can immediately understand what's going on, while in the previous solution it was just one line with a lot of stuff happening, and it was very difficult to understand, even though it was more concise. So this one is more verbose. And I personally think that this way of writing code is better, simply because you can just look at this and it's easier for you to understand what's happening. So yeah, I don't think like your colleagues will like you if you just produce very concise code. And production code is a code that is running in production. So this is like a recursive definition, but if the code that you wrote affects customers, then it's production code. And if this code is just running on your laptop and nobody can run it, then it's not production code. Andrew Ng course does not use Python. Do you still recommend taking it if ML mainly works with Python? Well, I took this course a while ago. So for me, back then, it was useful. I do think that doing something that immediately, where you use Python immediately, could be more helpful. I'm not sure what could be a good recommendation for that. I mean, this course, of course, is good, but I wouldn't compare it with the Stanford course from Andrew Ng, simply because they are very different. So in that course, you'll get a lot more theory. So this one is very practical, very hands-on. It's mostly writing code together. So yeah, so maybe you can just take both. So this I answered. In deployment, what do you mean by monitoring the quality, maintainability, and scalability of the model? So when you deploy your model, so let me just draw it again. So let's say you have your model. So this model is deployed, let's say, as a web service, meaning that if we have a phone, so let me just draw a phone that is, I hope it will look like a phone. So this is an old iPhone with a button. Right? So you have a phone, right? And yeah, so you have some details about the car, like about the listing, like title, model, make, and so on. And you want to predict what is the price of a car, right? So this phone sends a request to some web service, and then eventually this request ends up in a model, and that model replies. So it gets all the information about the car, like model, make, age, all these things, and then it replies back with predictions, right? So this car costs that much, right? And then this is what we recommend to a user, let's say 50K. So this model, like we say that it's deployed to production, right? Because a client can talk to this model, can communicate to this model using, like this is a web service. And they use, let's say, HTTPS to communicate to this model, right? So this is the deployment, right? And monitoring the quality means, let's say, now we deployed a model, and then 1 year after that, a car that costed 1 year ago 50 now probably costs 40, right? 40K. So cars change, there are new cars appear, and new cars are appearing. Cars that were expensive some time ago become less expensive. then maybe some cars become more expensive. So things change, right? And this is, we need to be able to detect these changes. So this is what we call model monitoring. Model monitoring. So we need to see if things we call these changes in distributions or drifts in distributions, if these things change, we need to be able to detect that and let's say retrain a model. Then where is the question? So scalability is, let's say, now you have not just one phone, but you have, I don't know, millions of phones. One simple web service cannot handle that many load, that much load. So what you need to do is deploy not just one instance of web service, but let's say, I don't know, 100. So 100 together can deal with 1 million requests at the same time, but one single one cannot. So this is what I mean by scalability. So we can scale our web service, add more instances of our model there to be able to process all this traffic. And maintainability, meaning, let's say, there is a bug in this model. So this bug. There is a bug in this model, and we want to fix this bug. How easy it is for us to fix this bug? Like, what do we need to do to debug the model, and so on. So this is maintainability, like how easy for us is to move around the code base for this web service. And usually, like if you follow best engineering practices, then it's easier. And this is not something we will cover in this course. So for that, you probably need a course on software engineering practices. And then, so actually I talked about model monitoring, but there is simple monitoring, like how many requests per second this model is getting, things like this. So for that, we also need to set up monitoring. Okay. Is it worth for a plus point if I share my experience on my personal public tech blog instead of social media? Yeah, I guess. Of course, I would like it to be about the course. Otherwise, yeah, I don't see why you should get a point. But yeah, if your experience involves the course and you share it on your tech blog, then yeah, of course, you don't have to use Twitter or LinkedIn. You can use any anyway, so you can blog. I think is perfectly fine. Okay, will you grade the homework? Yes, I will. So I haven't wrote a script for that yet. So what I actually want to do is, many people asked me how they can see the results. And I did a mistake at the beginning when I was letting people register, is I didn't add like a checkbox saying that it's okay to use some of the data, like let's say first name and last name in public. So I cannot really have like a public place, a public leaderboard where everyone can just go and check your score, because simply I didn't ask for permission to do that. What I want to do instead is to have to write again like a web service, where you'll have like an email field. So you go there, you put your email, and you get the scores. So this is only like an idea. I hope I'll be able to implement this. So hopefully it shouldn't be too difficult, and you'll be able to get your scores this way. But yes, I will grade the homework. I will keep the scores. I will store the scores, because at the end, if you remember from the first video, I talked about the public leaderboard at the end. And of course, for people, for the 100 on that leaderboard, I will ask them for the permission to publish their names. But yeah, before that, I'll need to figure out how exactly communicate the results of each separate homework. Yeah, but of course, like for me, grading is actually not difficult. I want to write a script for doing that. Could you create 2 Slido sessions, one for soft skill resources, career questions, and one for course content? Yeah, so for soft skills, resources, career questions, I would recommend you actually go to Datatalks Club Slack, and then there is a channel called Career Questions. So go there and ask your questions there, and use the Slido link for the course. So this way we can separate the two, and during these sessions talk about the course and not career, and maybe in the Slack we can talk about career. How many homework submissions were there this week? So let me check. So it's 404. Yeah, so somebody managed to do it right before I stopped accepting the responses. So somebody got lucky. I really enjoyed the first homework. The steps were pretty clear. Thanks. Thanks for saying that. It's nice to hear that you enjoyed it. So you will like homework 2 even more then. Can you please upload the live session recording and homework answers on GitHub? Yes, of course. That's what I'll do today. How many questions should be correct of each session in order to get the certificate? 0. So you don't actually have to submit homework to get a certificate. For the certificate, you need to finish 2 projects, so the midterm project and the capstone project. So this is what you need to do to get the certificate. The rest is optional. It will give you some points, but yeah, so if something happens and you don't find time to complete one homework, the world doesn't stop. So you can just catch up and perhaps do another homework. You will just not get the virtual points. But for the certificate, all you need is to finish 2 projects. I read in a book about the train def set partition. Do you know what is the purpose of this additional partition of the dataset and when this should be applied? Yeah, I think I explained that in the video. So yeah, just check it. It's yeah, you'll find the answers there. So I think it's model selection. It's called model selection. So I don't think I should spend time now explaining this. If you watch the video and you have questions about that, oh, actually you say trend def set partition. So yeah, sorry. So def in this case is the same as validation. So def is just for testing the parameters. So I think they usually refer to def the same way as validation. So when converting from data phrase to numpy array, is it better to use values or df to numpy? I don't think there is any difference, to be honest. I submitted the homework and sent the link to my GitHub link. Is that okay? Yeah, I guess it is okay. Can I still get the certificate if my first homework was late, but others are in timely manner? I think I just answered that question. Yes, you can. Deployed models work through APIs. Yes, they are. Do we need to scale the continuous features for? I think this is again a question that for week 2. So let's see what we also have. So why the mean didn't change after filling nonce? Yeah, that's an interesting one. So let's just go back to. So I'm trying to find my. Okay. So let's say we have a numpy array. We have some numbers here, like from 1 to 6, and we compute mean here, right? So mean is 3.5. So what we can do here is we add, again, this 3.5 multiple times. The mean doesn't change. So this is what happens when we have none here. So let's say we have a none here. So numpy simply ignores it. So it, sorry, pandas doesn't look at this. So it pretends it's not there. And it looks at, so let's say if this is none, I actually don't know how numpy works. Yeah, so numpy complains, but yeah, so basically what pandas does is it ignores these nonce. So it looks only at these numbers. And for this, it just pretends it's not there. And yeah, when we replace these nonce by min, and in this case is 3.9, so we get more data effectively. And yeah, the min doesn't change. I can try to show it with a formula. So let's say we have, so it will be a bit of math here now. So let's say we have our series, right? And then we have a couple of NAs. I hope you can see what we have here. So basically this part is usual values and this part is NAs. So this is the missing part. So let's say if we want to compute the mean of this, when we do dot mean in pandas, so what happens is, let's say we have n numbers like that and k missing values. So in total, we have our series is k plus n, the total length. So when we compute mean on just this part, what we get is 1 over n sum of xi, which we can call, let's say, x bar. So this is our mean, right? So this is, in our case, this is 3.5. Right? And now let's compute. So now let's replace these NAs with this x with a bar. Right. So what happens now is, instead of looking at the sum over, so instead of looking at 1 over n, we look at 1 over n plus k. Right, because this is the total number of elements here. So this is when we already filled in. And then we again have this sum, right, that we had before. And we have another sum of this, right, x bar, right? So we have k of this, and we have n of this. So this one here, this element is actually, so we can just because we sum k times this x bar, so it becomes kx. And this one, for this one, we can, so let's say if we have a formula like this, we can just multiply it by n over n. So n over n is, yeah, it's simply 1. So it's the same as just multiplying this thing by 1. Right, and this is what we get is n times x bar, because this part here is our mean. So for those who do not have a clue what I'm talking about, just bear with me, but it's almost over. So then what we have as the result is 1 n plus k. Then we have here, we have n times x bar. And here we have k times x bar. And now we can leave x out of this equation. So we have n plus k. Here we have n plus k times x bar, which is x bar. So basically, this shows that yeah, you can add as many means as you like here, and the result will always be x bar. So I'm not sure if everyone enjoyed this little proof, but yeah, this is how you can prove it. I got because I saw this question before the meeting, I got curious, like, how can I show this mathematically? And I spent like 10 minutes trying to figure out how, and it was a nice exercise for my brain, but I'm not sure I would be able to show this proof on the spot, to be honest. Okay. So let's see. Is there a hashtag or something similar to find the public learning contents of others? Yes, there is a hashtag. And the hashtag is hashtag ML Zoomcamp. So you can use that. You can put that in Twitter. You can put that in LinkedIn, and yeah, I think you'll find some posts there. And of course, if you can use these hashtags also for your own social posts. How hours of daily study is recommended, and how to study continuously without a long break. Well, to be honest, I don't know how many hours of daily study is recommended. That's why I added a question about that in the form. So I will share the results later with you, like how many hours usually takes on average. Yeah, so you will, I will share this information with you. But yeah, it's all, again, the answer depends on your background. If you're comfortable with coding, then for you, maybe you don't need to spend that much time as if you, like for you, like you're new to Python, for example, then you would need to put some more effort. So as for the numbers, or at the very least, maybe you want to watch the lectures first and then spend 1 or 2 hours on the exercises. Yeah, maybe in total 3-4 hours. Again, depends. So I don't really know. And how to study continuously without a long break. Yeah, like maybe you shouldn't study continuously without breaks. I don't think it's good for you. So better have breaks. Software engineer utilizes test-driven development. Since machine learning isn't rule-based, what kind of tests are written for ML projects? Yeah, so for that, you can do, for example, let's go back. So yeah, we have this model. So first of all, you can write integration tests. So here, let's say there is a tool that like you put this in Docker, right? So you set it up so it lives on your machine, and you can start hitting it with different HTTPS requests, and then you get some results. And then you want to first here test that the model doesn't take too long to respond, and then you want to look at the numbers, and then maybe do with these numbers, look at the mean prediction, the maximal prediction, I don't know, things like this. And maybe for some cars, you expect what kind of, it doesn't have to be a specific number, but let's say you can expect for a car like this, maybe the price should be between 40K and 50K. And if your model all of a sudden stops producing the price for this car within this range, then you look at this and you try to figure out what happened. So basically, again, you have a bunch of test cases for which you want to test that the predictions of your model are same. And if some of the tests breaks, you want to take a look at and understand why this is happening. Yeah, so mainly these two. And then, of course, there are some models. For example, we talked about this bug here. So maybe this bug has nothing to do with a model. It's just, data preprocessing issue. And for that, you can write usual unit tests. Okay. So yeah, basically for machine learning, you write the same tests as you write for usual software, except they're maybe a little bit different in nature because you expect here ranges, not always the same answer. I submitted mine with a link to GitHub. Good job. How did the plus come in the second last step? I don't know if you're referring to this. Yeah, maybe just watch the video afterwards and let me know if you have questions, because I'm not sure what exactly you're referring to. What is the program that you use for whiteboard during the course? I find it really useful to practice my thoughts for the interview. So let me share my entire screen, because I'm sharing only a part of the screen. So you see my entire screen now. So I use Windows, and this is Surface. So this is like a Windows tablet, and it's called Drawboard. So, and that's, if you just put it into your favorite search engine, you will find it. It's also available in, is it called Windows Store or Microsoft Store? I don't know, I'm pretty new to Windows. So there is some app store on Windows where you can just put this in, and it's actually free. So you can do a lot of cool stuff here. So for example, yeah, so you can write in, so I use only 2 colors mostly, but you can use a lot more colors here. Oops. Yeah. So yeah, it's a cool tool, and I have this pen. So this is all Microsoft. Okay, so let me again share a part of the screen. So maybe I don't want people to know that I have Windows. That's why I'm sharing only a part of the screen. Yeah, but I also don't want people to see like the taskbar, for example. So it's not useful. Okay. Yeah, that mean proof screen. How did you get the plus? Okay, so maybe you're referring to this plus here, right? So let me, and now since I have this, so are you referring to this plus? So let me maybe say it once again. So first, when we compute the mean without missing values, we use only that part of the array, right? And formula for that is this, right? So this is the formula for that. But now, let's say we include the missing values, and we fill these missing values with the mean. So this x bar, right? So now, instead of just having n elements, we have k more elements. So in total, we have k plus n. So that's why you have k plus n here, right? And that's how you have the plus here, because first you need to sum these elements, and then you need to sum these elements. So that's why you have the sum here. Yeah, I hope I understood the question. Okay, I'm happy to hear that. So this question was highly voted, and I kept postponing it. So when it's preferred to use my metric instead of RMSE, so we will not talk about this in many details. So oops. So let me use black. and RMSE are both metrics for evaluating the quality of regression models. So in the course we use RMSE, and is an alternative one. So RMSE, the formula is we look at the mean root squared error. So I think it's y minus, so this is the notation we use, g, right, and then we also need to square. So for the formula is a little bit different. So instead of having a square, like looking at squared error, we look at absolute error. So absolute means that we use these bars here. So it's yi minus g xi. Oops, yeah, so this is the formula. So they are a little bit different. So this RMSE, it penalizes very big errors. So let's say if our prediction is 0.1, but the actual prediction is 100. So this RMSE will get higher penalty because it's 99.9 squared. So this will be a huge, huge penalty. While for the first one, for it will be just 99.9. So like the pros and cons, you can just use both. So you don't have to choose one. You can always report both numbers. And maybe the last one for today. So we will have to do the midterm project and the capstone project. Do you have any idea in which month you will make these projects available for submission? So let's take a look at, yeah, so there is a course page. I think I have the dates there. Yeah, so this is the course page on Data Talks Club. And yeah, it says this is when we announce it. So midterm in October, then capstone in November. So I think for 2-3 weeks we will have them. Yeah, I think maybe 1 week before that, we still need to figure out how exactly to organize the logistics for that. So I think it will be judging by how many people take part. So first 2 weeks you will need to complete your project, and then the last week you will need to review the projects of others. Yeah, like it will be peer reviewed. Yeah, I don't know if I answer your question, but I think it should be possible to open it a bit earlier. But you will find the dates on that page. Okay, that's all for today. Yeah, so I hope you enjoyed the session today. So all the materials are already available on GitHub in the course repo. I saw that some people already submitted a homework for week 2. That's amazing. I think 3 or 4 submissions are already there. So enjoy doing this, and if you have any questions, feel free to ask them in Slack. So have a great day.